Hello, class. Today we're going to be working on lesson 13.6, apply measures of center and variability. Okay. And our essential question to start the day reads, what do measures of center and variability indicate about a data set? Okay, so we're looking at data sets again, and we're going to looking at the measures of center and variability. We're going to try to describe these data sets a little more. So, unlock the problem. Julia is collecting data on her favorite sports teams for a report. The table shows the median and the interquartile range of the heights of the players on her favorite baseball and basketball teams. How do the heights of the two teams compare? Okay. Now, if we remember, when we look at the interquartile range, it tells you one measure of how much the data varies. Okay. So when I talk about the interquartile range, is how the data varies. Okay. One measure of it. And then with the medians, we've worked with the medians in the past as well as ranges. Okay. So if you look to the right, the baseball team's heights, the median is 70 inches, and the interquartile range is 6 inches. So the basketball team's median height is 78 inches, and the interquartile range is 4 inches. Okay. So what that means is we have to fill in the blanks now. So we're going to start by looking along the line. So the median of the basketball players' heights is, we're going to say, 8 inches greater than the median of the baseball players. Okay, this one we're just filling in the blanks. We're looking at the median right here, and we can notice that the baseball team height is 70 inches, basketball team height is 78 inches, so it is 8 inches greater than the median of the baseball players' heights. Okay? Now we're going to move on to the interquartile range, looking at the 6 inches for the baseball team versus the 4 inches for the basketball team. Okay, so the interquartile range of the baseball team is, the baseball team up here at 6 is greater than the interquartile range of the basketball team. Okay, because 6 is greater than 4. The baseball team is greater than the interquartile range of the basketball team. So the heights of the baseball players vary more than the heights of the basketball team. Okay? And what that means, remember, it shows the range of the data. So that means if they have a higher interquartile range of 6 versus 4, that means the heights will vary more. Okay? The heights of the baseball players vary more than the heights of the basketball team. So the players on the basketball team are typically taller than the players on the baseball team. And the heights of the baseball team vary more than those of the basketball team. Okay, now let me just rephrase this and try to show you guys a little bit more. Okay, so understanding that the basketball team has a higher median by 8 inches. Okay, so the players on the basketball team are typically taller than the players on the baseball team because their median's already higher by 8 inches, 78 versus 70. But with the interquartile range, that means the variability in the data. So the baseball team has a 6-inch interquartile range, so that means that the heights of the baseball team vary more than those of the basketball team. Okay, so these are showing that the typical heights are taller for the basketball team, but the interquartile range shows that there's more variability. Okay, so as you watch, if you need to replay this little part a couple of times, understand this little portion and the difference between the median and how they're typically taller, and the interquartile about how the variability is varying more. Okay? Then we move on to down here. Julia randomly picks one player from the basketball team and one player from the baseball team. Given data in the table, can you say that the basketball player will definitely be taller than the baseball player? Explain your reasoning. Okay? Well, if you were to randomly pick someone from the basketball team and one person from the baseball team, are you going to automatically get someone that is a basketball player that is taller? So what we're going to say is no, okay? And we're going to say no because the median height of the basketball players is greater than the median height of the baseball players. But baseball players, but that does not mean every basketball player is taller. Okay? So understanding that if you were to randomly pick one baseball and one basketball player, although the basketball players' team heights they have a higher median of 78 inches versus 70, that does not automatically mean that every basketball player is taller based off of the median height. Okay? Median height's not telling us that automatically everyone is taller. It's just telling us the median height of their team. So that means they could have a shorter person, and one of their baseball players could have a taller person than 70 inches. Okay? Now, as we move on to the next page, okay, we're going to move on. Compare the means and ranges of the two data sets. Okay? So that's what we're going to do with these two data sets of t shirts sold. Kamara and Joey sold t-shirts during lunch to raise money for a charity. Table shows the number of t-shirts each student sold each day for 2 weeks. Find the mean and range of the data set of each data set and use the measurements to compare the data. Okay, so here's the data on the top right for Kamara and Joey. Step 1, find out the mean of each data. Recall the mean is when you add up all the data points and then divide by how many there are. So I'm just going to go down the line. 5 plus 1 plus 2 plus 1 plus 3 plus 3 plus 1 plus 4 plus 5 plus 5. Okay? And then you divide by how many there are. You just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So you divide by 10. So when you add all those numbers up together at the top, you're going to get 30. You're going to get 30. And then you still have to divide by 10. So 30 divided by 10 will get you 3. So 3 is the mean of Kamira's data set. Okay, now we move on to Joey. I'm going to go across the top again. 0 plus 1 plus 2 plus 13 plus 2 plus 1 plus 3 plus 4 plus 4 plus 0. Okay? And then divided by the same amount, which you would get 10 because they both have 10 in their data sets. So when you add all these numbers up at the top, you're going to get another answer of, I shouldn't say answer, total of 30. When you add them together. When you divide by 10, same thing like above. 30 divided by 10 will get you 3. So if you notice that Kamara and Joey, they both have a mean of 3, but different numbers in their data sets, different values. So now we need to find the range. Okay, now the range. Okay, what you need to understand is that the range, it tells you how varied the data set is. So range equals how varied the data set is. Okay, and in order to calculate the range, okay, you're finding the difference, so you're subtracting, as you can see right here. We're subtracting. Okay, you are going to subtract the maximum and the minimum data values, okay, of each data set. So if I'm looking at the minimum and the maximum, I'm going to look at Kamira's first, okay? So her maximum, if you look, is 5, okay? So her maximum is 5. Her minimum is 1. So 5 minus 1 will get us 4 for Kamira. Okay, that is her range. Joey's, his maximum is 13. His minimum is 0. 13 minus 0 will get you 13. So Joey's range is 13. Okay? So compare the mean and range. The mean of Joey's sales is the same, because if we're looking at the mean up top, the mean of Joey's sales is the same as the mean of Kamira's sales. The range of Joey's sales is greater than the range of Kamira's sales. Okay? So, the typical number of shirts Joey sold each day was the same as the typical number of shirts Kamira sold, because the mean, okay? The mean is telling us the typical amount of shirts they each sold. They both got 3, so it's the same. However, since the range of Joey's data was greater than Kamira's, the number of shirts Joey sold varied more. Okay, varied more from day to day than the number of shirts Kamira sold. Okay, so what we're looking at is when we recognize the mean, they both are selling the same amount of shirts, okay, each day based off of this data. But understand that the range will tell you that how varied the data set is that the number of shirts Joey sold varied more from day to day than the number of shirts Kamira sold. So Joey would have a different range of shirts that he'd be selling. It'd be a wide variety from day to day. Kamira would stay within a close range of her own. Okay. So last part is which measure of center would better describe Joey's data set and explain. Okay. So the measure of center that we would say is the median. Okay. We would say that the median of Joey's data set, and when we do the median of the data set, we would have to set it all up. The median is 2, which is close to the number of t-shirts Joey sold on all but one day, because we got 2 when his mean was 3. Okay, but just recalling, if you need to take a look at the range when you have to identify what the range is, how varied the data set is that, remember, it's wide variety. The mean is showing how much they're selling together. Same thing with the interquartile range up front. Okay, but the basketball and baseball. Okay, the median height says that the basketball team heights is greater, but that does not mean every basketball player is taller. Baseball teams' heights vary more because the 6 inches is higher than the 4 inches. Okay? So as you guys are going through your class kit today, make sure to take your time, ask your teacher questions, and if you need to, send it an email or through a private comment on ClassKick or on Google Classroom. Okay? Thank you guys so much for all this time, and we hope you guys enjoy it. Bye-bye.